Hello and welcome again to these chats that are sponsored by the Ronnie K. Urani Center for Energy Solutions of the University of Oklahoma. Today we're going to continue our chat that started last week regarding the future of the oil and gas industry. In the subtopic for today, we're going to talk about what actually you get from a barrel of oil. How do you use a barrel of oil? And what type of technology will be necessary to replace that barrel of oil in its entirety. With me, of course, is Roderick Perez. Carlos, our other speaker, excuses himself for today. He couldn't be here for us today, but he will be next week. And with that, Roderick, I believe you have news for us.
Yeah, I just want to say, hey, hello to everybody in the audience. It is always a pleasure to meet with all of you. And let's start with what is the current energy market situation right now. Today, October 13th, if we can see my screen right now, we can see that the WTI crude is below $90 per barrel. It has increased a little bit, especially for the economic or the economics news from the U.S. that you can share with us a little bit later, Luis. And the Brent is close to 95, as well as right now the natural gas is also in $6.6 per unit. And right now, also before we start, and it's also related with the news or the information that we have to share with you for all of the audience. We have a new course that we would like to promote, and if you are more interested, please go to this website, into the Irani Center for Energy Solutions at the University of Oklahoma. That is titled Artificial Intelligence for Renewable Energies. That is going to be taught by myself, and it's going to be between November the 7th to the 11th, and it's going to be 3 hours per day, and it's going to be very excited. But yes, now, Luis, there is a lot of, the people think that from the oil or the barrel of oil, the only thing that we can get is related to transportation, the gasoline, the diesel, the liquids, let's say. But what can you tell us about what is in the oil barrel? What can we do with it?
Well, let's go into the topic then. One barrel of oil actually can deliver a lot of products. Our friends from Visual Capitalist actually created a really good chart that I'm showing here for you guys, where you see essentially not all of the products, but the majority of the products that you can get from a barrel of oil. Those cover a wide spectrum of products. You can have gasoline to drive a car for about 300 miles, distillate fuel or diesel to drive a truck for another 40, 50 miles. If you include jet fuel, of course, you can fly a plane with this. 70 kilowatts hour of electricity at a power plant, about 4 pounds of charcoal, propane, asphalt. Most people forget that all the roads that we have are actually derived from the barrel of oil and they're asphalt. Lubricants, of course, for all the industry and all the engines and any type of motor will require lubricant, including, yes, the motors that we use in windmills, wax, for instance. But the most interesting part that I want to talk and discuss a little bit more is petrochemicals. We have plastics, polyester, rubber for tires, of course. In general, long chains of hydrocarbons that we were talking about this last week. Long chain of hydrocarbons that we use for everyday uses, from brushing our teeth, like you have here, toothbrushes, combing our hair, wearing a T-chair. I mean, you name it. Everything that is plastic, everything that looks manufactured artificially and doesn't look like metal is very likely going to be plastic, and then, of course, is going to be derived from oil. Now, the key issue here is how much of the oil or the barrel actually do you use for each one of these different products? And that's the key issue, really. If you look at this, and again, another really good chart that Visual Capitalist put together, you can see that about 40% of the barrel is actually used for gasoline, Another 27 to 30% is used for diesel, and another 6% ballpark is used for jet fuel. With that said, what this really means is about more than 70%, around 70 to 75% of the barrel of oil is used or dedicated for production of some kind of transportation fuel. You name it, diesel, gasoline, naphtha, jet fuel, whatever the name they use for the product. The fact is, 70% of the barrel of oil is actually used for those purposes. Now, the remaining 30% is used for the other products that we were talking, including tires, plastics, and all sort of stuff, including the production of natural gas too, and propane and butanes and several other products. But that's the key part. So transportation really, or running engines really, it's not just as much transportation. Running an engine, making an engine run, is really 70% of a barrel of oil. What do you think about that, Roderick?
Well, and it is important that the people take into account that gasoline, or let's say, yes, the fuel itself is not only like a regular liquid. It is a chain of a very special molecule that is the carbon that is, I think is, you tell me that if I'm right or wrong, but it's kind of unique in the environment because the combination of these carbons is, and the length of this carbon change is what make the fuel special. And this is something that we cannot find in other products and in other products in the nature. Okay, it may be an effort, for example, like to replicate this kind of change, long change in other, using other material or other materials or other molecules, but the uniqueness of the carbon change that we can find in the hydrocarbon, it's what it makes it special. For example, ethanol. Ethanol is one of these molecules that it could be produced by other sources, but the problem here is about economy. I mean, we can generate a lot of stuff, especially in lab environment settings, but in order to make this in a large scale, that's what it makes the current or how the world has been developed for the past 100 years with the with the democracy. No, like, let's go to say like the engine fuels, that the way that we know it has been the common. The common is because it has been everywhere since Drake found this oil in Pennsylvania more than 100 years ago. I mean, it changed the world in that sense. I mean, in the past, we were looking, or we were burning wax or the fat of the whales. I mean, we cannot come back to that.
That's a very good point. And one of the things I like to argue with several friends of mine actually is that it was the oil industry that saved the whales, not Greenpeace. Before, we were killing the whales to actually get oil and fuel our lights, and as a light source. And after the discovery of oil, of course, we switched to oil from the rock, hence the word petroleum. And the whale business actually went out of fashion because it was too expensive. It was much more better to get the oil from the rock. But you brought up an interesting point. Not all gasolines are equal. That's absolutely right. And before the Standard Oil Company actually standardized all these procedures, hence the name Standard Oil Company, what happened before was that every company has its own refining towers with different temperatures and different methods, and gasoline was very different. And you have problems with the engines, of course, because you were running gasoline from one company and then you replace the gasoline from a different company. You had all these kind of situations, and including, of course, fires in houses and a lot of issues. The Standard Oil Company, again, Rockefeller actually did this, standardized all these practices in one single company, and now we have this gasoline that is a little bit more manageable in that sense. But the important part that I want to discuss from this issue is that if 70% of the barrel is dedicated to transportation or running engines, if we can find an alternate engine, let's say an electric engine, then essentially we kill the oil industry, right? because 70% of the barrel is not going to be necessary. And that's the point that I would like to really emphasize here. That is a myth. It's not true. It's just not going to happen. Why? Because even with increased demand of electric vehicles, you will have also an increased demand for petroleum products for transportation. In other words, you're still going to need gasoline, you're still going to need diesel, you're still going to need jet fuel. And these petroleum products right now, in the latest forecast that the Energy Information Administration did about a year ago, and by the way, they are updating this every year. They have new numbers coming every year. But the consensus is still the same. Even with the increase of electric vehicles, even with the increase of electric engines, the petroleum products are still going to be required, because you cannot replace 100% of the engines to become electric from one day to the next. So demand for petroleum fluids required for transportation, for running engines, really is still going to keep going up, even if we introduce a significant growth of electric vehicle sales. And I'm going to come out of the closet here in a way. As a petroleum engineer, I am really pro electric vehicles. I think the electric vehicles are a really good idea. We do need them as a society. And if I can use a barrel of oil more efficiently, instead of spending 70% of the product in gasoline or transportation, if I can save a little bit of that barrel of oil, that precious liquid, a little bit more for other products like plastic and all that stuff, by all means, that will be welcome for me. That will be a welcome development from my point of view. That said, so if electric vehicles are not going to kill the barrel of oil, what do you really need to replace entirely one barrel of oil? Now, we have seen the products that we produce, of course. We need to replace a way of manufacturing those products that we get from oil in a different way. So we will need to begin with 100% use of engines that are not internal combustion. That means not just cars, trucks, that generator that you had at home when the power goes out and you use diesel to power your house, that needs to go too. And all kinds of engines that run on fuel. Anything internal combustion needs to disappear. First thing. Of course, that's not going to be an easy task. Second thing that you need is find a new technology that will power the aircraft and that will not require jet fuel. That's going to be very difficult because flight, of course, depends on the shape of the wing, of course, Bernoulli effect and all this physics phenomena, but it also requires speed. If a plane doesn't fly at a specific speed, you will enter into something that is called stall velocity. In other words, you will fall like a rock. And every pilot that knows his plane will have in mind every second that he's flying the stall speed of that plane. The planes actually have installed in their system alarms and bells and whistles that will sound every time that they are getting too close to stalling. And the only way right now to propel a heavy plane fast enough to actually lift it off the ground is via jet fuel. And unless we figure out something that is more powerful than that, planes are just not going to be able to fly, and the entire industry will disappear. And of course, that's not going to be an option.
Okay, Luis, in that sense, I think it is a rumor, or let's say in the middle long term, we might have some solution, and it's because, I mean, for everybody who has been in an electric car, I think one of the advertisement statement of Tesla cars or any electric car is that it can deliver a lot of power or the acceleration very quickly. The thing is that the batteries are so heavy that in order to get this effect to lift into the ground, they need to at some point we may need to have some batteries that which need to be light enough in order to have the same effect. But at this moment, we do not have batteries which are lighter enough.
Yes, that's a very good point. Actually, I have numbers for you for that. A Tesla Model X car, an SUV, that is the favorite car in the United States right now are SUVs. So the Tesla SUV is the Model X. The Model X is uh, weight-wise is more than 5,000 pounds. It's somewhere around 5,300 pounds, I believe, depending on the additions that you have and so on. So the equivalent SUV on an internal combustion engine, that will be something like, for instance, what Toyota produces. A Toyota SUV that is comparable to the Model X will weigh around 4,000 to 4,500 pounds. So you're
Or even
talking,
less.
yeah, we are talking about close to 1,000 pounds of difference between two cars that are essentially the same size and essentially run the same or provide the same service. And the reason for that extra weight is the batteries. The batteries that you need on the Model X are, of course, heavy, and that's the main culprit. Of course, there are other issues, but the main uh, weight factor that you need to consider in an electric vehicle is the batteries. You're absolutely right on that. The third thing that we need to remove or to figure out a way to replace entirely is a new material to create roads. Right now we use asphalt, and asphalt, of course, comes from crude oil, especially heavy oils. They are rich in asphalt. So we need to figure out a way to replace asphalt entirely. Hey, there are several ideas actually. I believe the Norway created a road that can actually charge itself and produce electricity by absorbing sunlight. So it's a road and a solar panel at the same time. Of course, it's expensive to produce, but one of the funny things about that is that it uses plastics. And of course, as we know now, plastics are derived essentially from polymerization processes from crude oil. So even that road is not entirely uh, free of crude oil. So we need to figure out technology that I cannot imagine right now. I just don't know if there is a technology right now that could replace entirely roads. My guess, of course, my educated guess is since we are not using anything other than asphalt to create roads, that technology right now doesn't exist. That doesn't mean that it will not exist in the future. It can exist in the future. Maybe we come up with new ideas down the road that could replace that asphalt. The fourth thing, of course, that we need to replace is plastics. And that is everything that you see. I mean, your computer right now, if you're seeing in front of your computer, that screen that you have there, that's plastic. Boom, that's crude oil. The keyboard that you have in front of you, that's your cell phone. Your glasses, the plastic in your car, the plastic in your home, whatever appliance you have at home that is electric is created and has a casing, let's say, that is made of plastic. And guess what? That comes from crude oil. So it's going to be very difficult to replace unless we figure out a way to produce plastics that are not derived from crude oil. And there are some research done about that, and there's some progress that we are doing about that. Right now, at current time, and I have actually data to show you, even though we have ideas of how to chemically produce a polymer without using crude oil, creating that polymer in industrial quantities so that we can produce it massively is cost prohibitive. So we still need to make, not just figure out a method to create the polymer, we need to create a method that will create the polymer and it will be actually economically viable. And as a matter of fact, I would like to discuss that. This is published August 28, 2020 by the Ohio State University, where they publish a paper where they show that you can actually make plastic without fossil fuels. This was 2 years ago again. And yes, there is a way where you can combine some ethyl particles or particles derived from ethanol and then combine them and create a polymer. But as you can see, 2 years down the road, we are not implementing those techniques massively, and we are not right now creating polymers using that method. It's possible, it's still cost prohibitive. We need to figure out a way to create polymers that doesn't require the use of oil. So as you can see, in the short term, really. And by short term, I mean 5 to 10 years. In the next 5 to 10 years, it's going to be extremely unlikely that that we can replace a barrel of oil. Extremely unlikely. In the medium term, let's say 10 to, let's say up to maybe 50 years. From 10 to 50 years is still possible, but still unlikely. Because not only you need to create the method, not only you have to come up with the scientific discovery of how to replace this production that we use oil for. Not only you have to come up with that, you have to come up with an economical way to do it. But in the long term, and I'm talking long term, more than 50 years, I'm not going to say it's impossible. Of course, it's possible, and with new technologies, yes, we can do that. Is it still possible that we can replace a barrel of oil? Yes, it is possible. That said, we've been running on oil for longer than 120 years, and still haven't figured out a way to replace it. So it's not an easy achievement, but it's not impossible. The more likely outcome, however, is not that we are going to figure out a way to just get rid entirely of oil. We're going to figure out a way to make more efficient use of that barrel of oil. So maybe in the future, you don't need 70% of the barrel to produce fuels. We can figure out a way to produce alternative fuels like solar, wind, to produce electricity, and more cars are going to be running electric vehicles. So only a half of the barrel might be used for transportation, and we can use those other particles and all that other volume for different processes. And new processes actually come up also on the oil industry. So constantly we are figuring out more efficient and better ways actually to use that barrel of oil. So science doesn't only go fast in the direction of environmentally friendly electrical vehicles, it also goes fast in the direction of internal combustion engines and in the direction of the use of a more efficient use of petroleum fluids. And that's the beauty of it. Science doesn't restrict itself to just one area of one single point. So the most likely case that I see for the future is that we are going to have oil, but it's going to be used a little bit differently than it is used today. And we're still going to need oil, but maybe we're not going to need oil in the same quantities that we need oil today. To have an idea, right now, the world consumes, give or take, about 100 million barrels of oil per day. Maybe down the road, we can make it up with 90 million barrels of oil per day. Maybe in 50 years, we can do that with 80 million barrels of oil per day. I don't know. Technology will dictate that. But I don't see it right now. And of course, economy. The one thing I don't see really, I don't know if you disagree with me, Roderick, is I don't see how in the future we're going to go to 0 barrels of oil per day. Do you think that that's even an option?
Well, I think it's definitely not. I mean, again, there is some physical reasons and certain mechanical and physical properties that the oil is the only product in the nature that can provide it, unless we take it from animals, which we were talking before, the fat of the whales, which is also something that is totally insane at this point.
We don't have enough whales.
That's true. And maybe in the long term, we might think like, okay, 0, but maybe if we can recycle all the oil that we already extract and we put it back again, but it's more like to continue using again these properties of this carbon change that already has been produced. I mean, that if we have it available, and I mean, but this is a resource that we have and we need to use, and in some way or another we need to continue using it.
Yes, and I see that you're in agreement with me. Right now, if we're going to do that, to achieve something like that, we need to go into what today is really science fiction. And what you mentioned, for instance, recycling oil right now, and figuring a way to recycle the oil, and okay, it's possible, but right now that is something that we cannot do really realistically. Therefore, it's still science fiction. That doesn't mean that down the road, we, as crazy as it sounds, we figure out a way to do it. Yes, it's possible. Every time that I mention that it is possible, people see significant chances. They think that possible is a word that increases the amount of chances. By possible, I mean few chances. That's why I'm saying in the long term, it is possible, but still unlikely. There's not going to be more than 50% chances that down the road we're going to replace and have 0 barrels of oil. Quite the opposite is the chances of us replacing oil entirely, maybe 50 years down the road. If you have to venture a number, we can say it's 20, maybe 30% chances, which still means there is a 70% chance that we're still going to have to make some production of oil coming online so that we can use it and distribute the products that we get from it. And by the way, every time that I mention this, they always is a guarantee that you're going to get this question. Always the question is, but how about renewables? All we have to do is increase renewables, more solar energy and more windmills, and yes, we can replace entirely oil. Well, what is the problem with renewables? Solar, wind, hydroelectric, and other forms of renewable energy are mainly dedicated to produce electricity. In other words, the windmill that you see in the plains or in the areas where you can see those, that windmill is going to rotate, and that rotation is going to move a motor, an engine, and that engine is going to produce electricity. The same can be said about solar panels. Solar panels gather energy from the sun, and that transformation of that energy becomes electricity. The amount of oil, notice that when I showed the graphs at the beginning, the amount of oil dedicated entirely just for the purpose of creating electricity is actually very small. Very close to 0 if you think into a worldwide situation. The amount of energy that you actually use to produce electricity, or the compound that you use to produce electricity right now, is coming from natural gas, which, by the way, is also an hydrocarbon, and of course comes also from oil wells. So why is that? 20 years ago, if you were asking me what is the main source of electricity, for instance, in the United States, 20 years ago it was coal. But today it's natural gas. What changed? A lot of people think, oh, it's the regulations and the laws and the environmental laws that killed the coal industry. No. What killed the coal industry is this baby that you have in this picture here. It's called the combined cycle schematic of a plant that generates electricity entirely from natural gas. To make things quick, when you have a coal plant, you burn the coal to heat or overheat water to produce steam. The steam is going to go into a steam turbine generator and produce electricity. With a combined cycle natural gas plant, what you have is 2 sources to produce electricity. You have the steam, you can use the gas to power an engine, a turbine. Think of about a similar, but not exactly, but think of the kind of turbines that you can see on a jet engine. You use natural gas to produce or move or generate the movement of that engine or that turbine. And with the movement of the engine, you can, just like the windmill, generate electricity. That's the one source of electricity that was going to come here. But the engine, because it's burning natural gas, also is going to produce heat. And you can use that heat from the engine or the turbine to feed that heat into a steam turbine generator, like any coal plant, and produce electricity also from the heat on the engine. So you kill this bird with 2 stones, really. So you're not overkill. You're producing energy in 2 different sources. You're producing the energy, the electricity coming from the turbine, that is natural gas power, and you produce electricity coming from the steam turbine generator, coming from the heat that the natural gas powered turbine produces. Of course, this is more efficient. The efficiency ballpark, I'm talking round numbers, the efficiency of a coal plant today, it might be, if it's very well run, might be close to 35%. But the efficiency of a natural gas plant, even if you run it poorly, is higher than 60%. So you're almost doubling the power, the capacity of generating power with natural gas. That's really what killed the coal industry. Because now we can produce enough quantities of gas to power these plants that are more efficient, less pollutant, less contaminant, and, of course, cheaper to manufacture. By the way, if you are going to manufacture a plant like this on a combined cycle, you might spend, I don't know, 150, $200 million to produce a small plant. The equivalent small plant that it will be powered by coal is going to cost probably twice as much. Which is why last week I was saying that if you work in a power industry, if you work in an electric company and you go to your boss and you suggest building a coal plant to produce electricity, at that very moment you're going to get fired. Because right now, that's really not no longer an option. So renewables are very interesting. We do need them. Again, as a petroleum engineer coming out of the closet, I am pro renewables. I think that they need to happen. And I am really happy to see windmills and solar panels in my neighborhood all the time. However, pretending or imagining that renewables alone can replace entirely uh, what you get from hydrocarbons or fossil fuels, that to me is just, I mean, completely out of your imagination. It's just not going to happen. It's magic thinking.
Well, now combined thinking about that, Luis, I think it's a very interesting what you were talking, and also another topic that since right now we're ending the talk, it's about not only the efficiency in terms of the renewables in general, but it's about also the that I mean, in general, especially in Latin America, I'm talking about in my experience in Venezuela, Colombia, where we have a lot of rain, we may generate electricity due to hydroelectric power. Okay. However, the issue with the electricity and the energy and how the dynamics of the economy works in the entire planet, okay, is that the majority of the countries located around the equator are not the most developed countries, and maybe their energy requirements are not as high as, for example, the countries located at the North Pole or close to the away to the equator, okay, where the requirements of energy are higher due to the higher GDP and higher power necessities in order to generate products. And sadly, that's not where the rain happens, okay? And one of the key issues, I think, and I would like to hear your opinion about that, is that the barrel of oil or the barrel as a physical measure and as a container is that you can chip, you can move it, whatever the necessity is. You can, for example, in the case of Venezuela, which has the one of the largest or the largest oil reserve in the world, I mean, you can chip energy from point A to point B, and if that's one of the key elements that with other sources of energy you cannot do it. Okay,
Yeah,
what do you think?
yeah. I actually make an analogy, and I tell people, don't think the barrel of oil is that black substance that looks ugly. Think of the barrel of oil as a big battery, which is really what it is. It's a barrel of energy that you have condensed, and you can move from one direction to another to generate whatever you want of regarding energy. You can generate electrical power, you can generate diesel, you can generate gasoline, you can do whatever you want with that barrel of oil. So if you think of the barrel of oil really as a battery, you understand really the effect really that oil has in the world. Why? And this is the key driver for the next slide. The main problem with renewables, it's not just efficiency and all those other issues, but the main problem with solar and wind is that they cannot produce energy on demand. Let me explain that in more detail. If I am right now consuming 100 kilowatts and I need them right now, and out there is no sun or there is no wind, I'm not going to be able to get 100 kilowatts. And the same happens the other way around. Let's say right now I'm producing or demanding only 50 kilowatts because it's mid-afternoon and I already finished cooking and everybody's just watching TV. If I am consuming 50 kilowatts and I need 50 kilowatts and out there is really sunny, the electrical generation capacity of those solar panels could be exceeding that need. It could be 150, 200 kilowatts, but they are going to only sell me the 50 kilowatts I need. The remaining kilowatts are just not going to be used. They're going to be wasted because they cannot be stored as efficiently as oil. We cannot produce a battery right now that is just as efficient as a barrel of oil. We are getting close and better. And if you have installed those Tesla batteries that you have these days with solar panels, of course, that Tesla battery can hold its charge for a good day or two, depending on your demand. So you can power your home for a few more hours than, let's say, 20 years ago. But today, we still don't have the capacity to chemically produce a battery that is going to be just as efficient, full of energy, like a barrel of oil. What that means is every time that I'm generating excess energy, it's just going to get wasted. Which is why when there is really a lot of wind here in Texas, for instance, I see it all the time over my window. I can see the windmills rotating, and at some point they stop. They're generating too much electricity. There is too much wind, and we don't need that amount because the demand right now is too low. So they stop the windmills, even though there is wind. And the same happens everywhere.
But it's also it is another topic that we can go through, and it's a mechanical reasons that they need to stop the windmill because, of course,
that is because the windmill might be rotating too fast. If you have tornado type of winds coming at your engine, the rotation might be too fast and overheating the engine, and then yes, you break the engine and you protect it. But in general, if you are generating energy, let's say you have enough wind to generate 100 kilowatts, but the city is only demanding 50, guess what? You're going to have to shut down half of the windmills because you only need 50 at that moment.
Yep.
So the only efficient way to really get energy on demand is with a natural gas plant or essentially a fossil fuel type of generation, or, like you mentioned, hydroelectric power. But the hydroelectric power has another problem. Hydroelectric power is limited to the amount of water that you have available. And you mentioned Colombia, for instance, and Venezuela, and in those two countries, as a matter of fact, every 50 years or so, they have a drought that is strong enough to essentially shut down the country. And I'm talking industry-wide, households, you name it. When I was a kid in Colombia, I experienced this situation when the hydroelectric power generation capacity was not enough because we were going through a drought. And the cities, and I'm talking the big cities, Bogota, Medellin, all the cities in Colombia were taking turns and shutting down at night and taking turns on who can use power for how many hours at a time to run enough electricity just to keep everybody sort of okay for a few hours and then dark for the remaining ones. And that's the main problem with hydroelectric power. Again, the only way of generating electricity on demand efficiently right now is fossil fuels. Can we figure out a better way in the future? Of course. I'm open to ideas, I'm open to suggestions, I'm open to all kinds of possibilities. Right now, the technology to replace fossil fuels for the generation of electricity entirely is just not there. We don't have that technology. We don't have that capacity yet. That doesn't mean that we can't. Maybe in the future. In conclusion, and you're right, we're finishing the discussion. Entirely replacing a barrel of oil, it's extremely difficult, and I will say it right now, close to impossible. But new technologies are invented every day, and they can happen. And yes, replacing a barrel of oil is within the realms of possibilities. But in the meantime, we are going to have to use fossil fuels still, and we're going to have to support the industry, and we are going to have to figure out a way to make the industry better, more environmentally friendly, less contaminant or pollutant, more efficient, in ways that we can, survive to reach the point where we can actually replace it entirely. Funny to mention, in April 2022, an article came up where Stanford researchers got solar panels to produce electricity without sunlight. And they did. If you read the article, they figured out a way to make the solar panels generate electricity at night. Of course, the problem is they don't generate enough electricity as compared to during the during the daylight. So the same amount of solar panels will just barely generate enough electricity to power maybe a home when during the day they were powering an entire neighborhood. So that's the analogy that I have here. But that's good news. Still, we are still far away from actually replacing or generating electricity for the entire day, for the entire 24 hours using solar panels. But it's not out of reach. It's not something that is entirely out of reach. It's something that could happen down the road. But that road is still long. It's going to take time. And we're going to have oil and the oil industry for many years to come. What do you think, Roderick?
Yeah, I think at the end, everything reduced to efficiency and economy. If there is enough, as is right now, I mean, if there is enough incentive and it's enough also awareness of the people to be more efficient in general, I think it will make everything more viable at the end. Okay, and
Yes.
it's going to be the same with water, with paper. I mean, with everything. I mean, at the end, everything to reduce to an economy of the scale, and if we can afford and the value or the prices of these elements or resources are in a certain range, then the adoption it will be better.
Yes.
I mean, for example, I think there is a lot of a topic of education. I mean, right now, this headline that you mentioned here, that they produce electricity without sunlight. The people may think that the sunlight or the sun is the one who produces energy, but at the end, we need to go through more deeper and try to understand that light is energy, and then we need to, what these people, what they did in a very smart way is to catch these frequencies and so on. I mean, there is a lot of education and a lot of research need to be done, and I think it's a very passionate world to be. And yeah, we are not going to rid of oil. We don't need to see it as the enemy, in the same way that probably in the 70s the people saw the nuclear power as the energy after Chernobyl. I mean, I remember someone who said, like, everybody wants, or I mean, at the time, the people wants nuclear or energy produced in a clean way through a nuclear reactor, but no one's want a nuclear reactor in the backyard of their houses, of course. But there is a lot of things to talk about, and this kind of opens discussion that we're having right now. And thank for the audience to listen to us. And if you have any comments, we'll be more than glad to share. And thank you, because this is the kind of things that it will help us and the audience to be more knowledge about these topics.
Yeah. Thank you, Roderick. Yes, what you mentioned is important. The economies of scale are really important. One thing is it's a dual challenge. We need to figure out a way to do it, and it has to be economically viable. Without the economy or the idea that we can do this in industrial quantities and generate big quantities of electricity or energy or whatever it is, replacing oil is going to be difficult. The oil industry has a little bit been vilified, sometimes for reasons, but most of the times, in my perspective, most of the times without a justifiable reason. Again, you go ask any of your friends that are not in the oil industry if they think the oil industry saved the whales, and they're going to tell you no. And then you're going to have to explain why. Not only it's true that the oil industry saved the whales, it's a fact. And the only reply that sometimes I get from friends when I discuss about this is that the oil industry was not intending to save the whales. My only reply to that is, yeah, the intention was not to save the whales, but tell that to the whales. Tell that to the whales. Look, capitalism works that way. Sometimes you get really good effects, good unintended consequences, and you should be happy for that. But there is a fact, and the fact is we replace whale oil using petroleum products. And that is undeniable, and that saved the whales. So thank you for your time, Roderick, and thank you, everybody, for listening to us, and hope to see you guys next week.
Yeah, definitely. Thank you so much for everything, and keep in touch. Have a wonderful day. Bye-bye.
Have a good one.